Welcome to Array Math Part 2. This video will cover array division in MATLAB, ultimately finishing with how to solve a set of linear equations using MATLAB, brought to you by the First Year Engineering Learning Center. Matrix division, again, is also by linear algebra rules. It uses the identity square matrix and something called the matrix inverse. Division can be both left-handed or right-handed, depending on what symbol or what order of the matrices you have that you're working with. The identity matrix is like multiplying any matrix by 1. It has ones down the diagonal and zeros everywhere else. In order to multiply the identity matrix by any other matrix, the inner matrix dimensions must match. When you multiply by this matrix by 1, you get the matrix back in the same orientation. If we flip the order of the identity matrix, we would have to then flip this. It used to be a column, now it's a row, in order for the inside matrix dimensions to match. Multiply this by 1, you get the same values, it's just now a column. The identity matrix is like multiplying by 1. The inverse matrix is a square matrix. It's the opposite of the original matrix, such that the matrix multiplied by its inverse in either order is always going to answer or yield the value of 1, or the identity matrix. So the command for finding a matrix's inverse is this built-in MATLAB function, INV. So here's some matrix. We want to know what's its inverse so that this times this will give us 1. Let's try this example. So I've set up our matrix 2, 1, 4, and 3, and I want to find its inverse. So if I say B equals the inverse of A, B is now these values. So notice that these values could be decimals. And now let's see if A times B, A times its inverse, should give us the identity matrix, and it does. And it's commutative, which means I can flip the order. They're both square matrices, so that inside matrix dimensions will match. B times A is also the identity matrix. What if I want to know if a matrix even has an inverse? Well, I can use the determinant function to determine whether a matrix even has an inverse, even before I create an inverse. So this might be a good way in your MATLAB programs with using some logic here to check that a matrix has an inverse even before you try to even create one. And so when you do the determinant of a matrix, it's like using linear algebra rules, it's the product of the two diagonal minus the product of the two opposite diagonal. And that value will be a number. It'll be a scalar. If that determinant, if the absolute value of that determinant is equal to 0, then this matrix has no inverse. In other words, if you tried to take an inverse of this matrix, you'd get an error message in MATLAB because it wouldn't give you one, and there is no one. So we might want to find out if a matrix has an inverse before you start using that INV function. If the scalar is any value other than 0, then the matrix has an inverse, and you can do array division. So let's go and look to make sure that A even has an inverse. We're going to go back one step. Okay, so we're just going to say, what's the determinant of A? DET is a built-in MATLAB function. So it has an answer of 2. So that means if it's a non-zero value, then that matrix A has an inverse. And then all the calculations that we did beforehand are valid. All right, so how can we use this to our advantage as engineers using MATLAB in our problem solving? Well, the left-hand division is when you've got A, a matrix, X is your unknown, and B is a known matrix. So X would be the unknown. It's kind of like the equation AX equals B. And you want to solve for X. Now remember, in MATLAB, A as a matrix could represent one scalar, or it could represent 10 or 100. Same thing with X. It could represent one scalar or several, and B. So now looking at this from a linear algebra perspective, let's take AX equals B, and let's multiply both sides of the equation by A inverse. because if you multiply two sides of the equation by the same thing, you're not changing their relationship. So, and we're going to multiply both sides of the equation to the left of what is here. So we have ax equals b, multiply both sides by a inverse. We know that this together, a matrix multiplied by its inverse, is just the identity matrix. So this simplifies to just the I. We'll leave this here. And any matrix multiplied by the identity matrix is just itself. So now we've been able to isolate x, just like we would in algebra. X is now going to be equal to the inverse of A times B. Or in MATLAB, the syntax we could write would be X equals A left hand or backslash left backslash B. Or we could use the INV of A to get this right there. So let's try an example in MATLAB. So here are our equations. We have two equations and two unknowns. 3x plus 5y equals -7. 2x minus 4y equals 10. You might see this kind of a problem. This is only two equations and two unknowns. In engineering, you might see something a bit more complicated, like 5 equations, 5 unknowns, or 10 equations and 10 unknowns. And so, although we could probably solve this one by hand, we don't need to. MATLAB can do this for us, especially if this was more equations and more unknowns. We're going to take advantage of MATLAB's power. So we're going to set it up. Remember the equation or the template was a matrix times its unknown, some unknown matrix is equal to the b, or the constant values on the other side of the equation. So we've got to look at these equations and we've got to put them into the format ax equals b. We have to remember our matrix multiplication rules. So essentially what you do is you take the coefficients in front of the x's and the y's, and you put them here in this matrix, and for the second equation you would put them here. And then you take these constants that are on the right-hand side of the equation, you put them in this matrix B. So what we've done is we're not changing this equation, because if you did your matrix multiplication, 3 times x plus 5 times y equals -7. That's the first equation. Multiply this matrix by this matrix, we get 2 times x minus 4 times y equals 10. Now, so we've got the format, we've got the coefficients in a format a times x equals b. We're looking for these unknowns x and y's. So in MATLAB, we would enter in a equals this matrix, we enter b equals this matrix, and then we look for the unknown x matrix, and whatever coefficients come out for x, we know that it's going to be in this orientation, a 2 by 1. So we can use any notation to do it, either inverse a times b or x equals a backslash b. Let's try it in MATLAB. All right, so I've set up our a matrix, 3, 5, 2, and -4, and our b matrix, which is -7 and 10. This is a 2 row by 1 column. This is a 2 by 2. So now I want to solve for my unknowns. X is going to be the inverse of a times b. So there's my answer. So now x is 1 and y equals -2. Those are the unknowns. MATLAB helped me solve for those unknowns. An alternate calculation would be equal to say x equals a left hand backslash b. And I get the same answer, 1 and -2. So in this set of two equations, two unknowns, x equals 1 satisfies both equations. Y equals -2 satisfies both equations. So if I use MATLAB to plot these two equations, 3x plus 5y equals -7, 2x minus 4y equals 10, I could write a little program that generated a whole bunch of values of x's and y's and plot these two lines. So these would be two straight lines, and where those two lines intersect is the solution, the same x and y coordinates that solve both equations, which is where they intersect. X equals 1, this is the x-axis, and y equals -2. So where those two lines intersect is the solution that we're looking for. Now what happens if we did right-hand division? And let's say your order of your matrices is slightly different. It's really a preference depending on how you want to approach solving linear equations. And so instead of having ax equals b, we now have x times c equals d. And using algebra rules, we're going to multiply the right side of both sides of this equation by the inverse of c. So we have this on the left-hand side. We've multiplied both sides by c inverse. These combine to be the identity matrix. These two stay the same. Any matrix times its identity. The identity matrix is the original matrix. And so we've been able to isolate, again, x represents the matrix of unknown variables, little x and little y. And so if we wanted to solve, we could say x equals d times the inverse of c, or the other syntax in MATLAB would be x equals d / c. So let's go back. We've got our equations. Let's say we're solving these for the first time, and we're going to use the right-hand division. And so now we have to set up our coefficients of c and d in a slightly different way. We have to transpose the matrices, because now x comes first. The unknown matrix of x and y. In this example, if we were going to flip the order, we have to transpose the x and the y. So we have a 1 by 2. We also need to transpose the coefficients that are in our equations. So 3 and 5 go here, and 2 and -4 go here. We transpose the constants compared to the left-hand example, and we put it here. This is all so that when we do the matrix multiplication, we follow the right rules. Inside matrix dimensions match here and here. A 1 by 2 times a 2 by 2 is going to yield a 1 by 2. So we've got 3x plus 5y equals -7. Multiply these two together. 2x minus 4y equals 10. Okay, so we've had to transpose these a little bit differently. So C is not identical to A, and D is the transpose of the B matrix. So we have to be careful of that. And in this example, we're going to check to make sure that C even has an inverse before we start looking for it. So let's do that in MATLAB. All right, so I've set up C, which is the transpose of A. I've checked its determinant. As long as the determinant is a non-zero number, then we're good to go for having an inverse of C. I've set up D, which was really the transpose of B, using this right-hand division example. And now I'm ready to check what the unknown matrix X is. I can solve for the unknowns little x and little y. So I'm going to say D times the inverse of C. Notice the order that I'm doing this in. And I get that little x is 1, little y is 2. An alternative calculation would be x equals D / C, and I get the same answer. So these examples just show you that there's alternatives for solving a system of linear equations, whether you use the left-hand division or the right-hand division. Just recognize that anytime you have a system of linear equations and you're trying to solve for the unknowns, you might see this type of problem in chemistry or any of your other engineering or calculus courses, or even in physics. MATLAB is a powerful tool. That concludes Array Math. Thank you.